we're going to look at kinetics. Kinetics is a fancy word for rates. So because this is a chemistry class, we are more concerned about rates of reactions, but let's look at how rates are used. So typically a rate is a unit of some kind over time. So if we look at a unit can be anything from miles, centimeters, it can be a length, but then also we're going to always have time on the bottom. It's going to be something over time. So you want to look for time, and the time could be hours, seconds, minutes, but that gives you the idea that it's a rate. If it's something over time. Why do we even care about rates? Well, if something happens too fast, too slow in your body, for example, hypothyroidism, then you're going to be ill if you don't take care of it. If reactions happen too fast in your body, that would be an example of hyperthyroidism, and that also could be detrimental. Okay, so let's look at graphs. You are going to have to both interpret graphs and make graphs in this course, because that's how chemists look at reactions. So, for example, let's say that you have a graph of time. Let's put it in seconds in this case. And we're always going to have time on the x-axis, always. And in this case, we're looking at concentration of some molecule A. So what's happening is we have a nice linear progression of our data. And this is the typical y equals mx plus b. So if our y is concentration of A, that's from our y here, and then our slope is m, and then our x is time, and then our intercept is b. So we're going to use the y equals mx plus b, which is your equation for a line. In this case, you notice the y-intercept is 0. It doesn't always have to be 0, but in this case it is. And were you to calculate the slope, you would pick well, first of all, you would draw a straight line. And then you pick 2 points, not data points. You don't ever pick data points because you want to use the average. So we're going to calculate the slope, and then we have units. The units is going to be molarities over seconds. Okay, let's look at another graph. This graph has time in seconds here, but if you notice in this case, we're taking the natural log of the concentration of A. We are going to be using natural logs, so you want to be able to do that on your calculator. So this is our y. So if this is our y, natural log, then that's our y for y equals mx plus b. And then the time, because that's our x, and then the slope, and then the intercept. So in this case, your y is natural log of a. And notice this is linear, but it's going this way instead. Okay, so we're looking for another graph. In this case, we have a graph where we have seconds again for the time. but we have 1 over concentration of time. That's our y. So this is our y. So it goes here into our y equals mx plus b. So here's our y equals mx plus b. In this case, notice the y-intercept is 100, so you do have a value here. So those are the 3 most common graphs that we'll be looking at in this course.